Hi class. So we're starting week 5 already. I know many of you have done a really great job with getting together with your groups and starting to figure out what it is you're going to study, and each of you are coming up with some really fun topics. So it's really fun to see you guys all kind of generating things and learning the concepts and putting it into practice and brainstorming and all of that. So be sure to schedule some time with me if you feel like it would be beneficial to your group to just run some of your research ideas by me, or ask some questions on the concepts of your independent or dependent variables, or how to operationalize things, or whatever you feel like might be helpful. So this week, week 5, we're going to be talking about measurement concepts. And so one of the concepts related to measurement is reliability. And reliability refers to the consistency of or stability of a measure. So your everyday definition of reliability is quite close to the scientific definition. So for example, you might say that a professor, let's say Professor such and such, is reliable because she begins classes every day at 10 a.m. So that's the concept of reliability from kind of an everyday standpoint. So another way to think about reliability of a measure is to think about the concepts of a true score and measurement error. A true score is someone's real, true value on a given variable. The difference between a true score and a measured score is measurement error. An unreliable measure of intelligence contains considerable measurement error. Thus, it cannot reflect an individual's true intelligence. So that kind of gives you some example of measurement error and the reliability of measure in terms of when we're thinking about the reliability of measures that you may be coming up with or thinking about. The correlation coefficient that's most commonly referred to when discussing reliability is the Pearson product moment correlation coefficient. And the Pearson correlation coefficient, that's a mouthful, is symbolized as R, and it's an italicized R. And it can range from 0 to +1 and 0 to -1. So a correlation of 0 tells us that two variables are not related at all. The closer to 1, either positive or negative, the stronger the relationship is. And so if the relationship is positive, it's going to be a positive one. And if it's a very strong relationship, and if it's negative, it's going to be a negative one. So that gives you the information about the direction of that relationship. Okay? The next concept that we'll talk about as far as measurement concepts is test reliability. So test-retest reliability is assessed by measuring the same individuals on a particular or at 2 points in time using a particular measure. So for example, the reliability of an intelligence test could be assessed by giving the measure of a group of people on one day and then again a week later. One would then have 2 scores for each person, and a correlation coefficient could be then calculated to determine the relationship between the first test score and then that retest score. So high reliability is indicated by a high correlation coefficient showing that the 2 scores are very similar. So given that test-retest reliability requires administering the same test twice, the correlation might be artificially high because the individuals remember how they responded the first time. So alternate forms reliability is sometimes used to avoid this problem. It requires then administering 2 different forms of the same test to the same individuals at 2 different points in time. Okay, and so that's some information about some of that reliability. I'm going to pause and start a new video just because it seems like the longer the videos are, the harder they are to upload. So we'll talk about some other forms of reliability when I post my next video.